Here's how I solved it. Understanding those crazy data types. You know, those tags with letters and hashtags, things like pound 99999. I had to learn not just how to read or move it, the data, but why sometimes the data looked weird. Let me ask you, you've been struggling with those types of uncommon data types like I did? When you open a PLC program, you probably see some crazy looking data. I know when I first started, I thought I was missing something that senior engineers just knew a secret. They knew programming in a way that I hadn't learned yet. But the truth was this. Most of the time, the problem wasn't the data itself. The problem was I couldn't interpret it. I slowly started to discover that in automation, understanding what I'm seeing, that's freaking half the job. If I don't know what the kind of data is coming in, I don't understand what it's doing. I'll never understand what my system, what my program is supposed to do. I needed to learn how to interpret the program. Traditional training, it kind of teaches us that inside a PLC, the data lives, kind of like in a natural form, binary, integers, floats, and bits. They kind of always exist as raw numbers. Where things got interesting for me is when I started seeing data types like ASCII, DINT, or formatted text such as pound 99999, right? It took me a while to learn the key lesson there. Yeah, but before I go there, I want you to stick with me to the end because I'm also going to share with you a tool that's going to help you troubleshoot a PowerFlex 525 as well. So we'll get to that. Now, when I see an ASCII or formatted data like the pound 99999, I discovered after digging into the PLC program that I'm looking at incoming data. A senior engineer didn't write that data that way. It came from somewhere else. A barcode scanner, a scale, a printer, or a vision system. Devices like those, they send information to the PLC in a form that they understand. Strings, characters, formatted codes. And it's my job as a programmer to convert it into something the PLC can actually use. I didn't know that at the time. Thought I was missing something, some hidden trick that a senior programmer used, right? Looking back, it's actually almost funny. A PLC never takes an integer, turns it to ASCII, and uses it internally. That's not how processors work. ASCII is for communication, not computation. At first, whenever I saw that kind of data, I immediately thought I was dealing with, inputs or outputs or some sort of internal logic. I recall that, that simple glimpse into how data works. It began to change everything for me. It was like for the first time, I started seeing data as communication instead of confusion. Understanding where the data comes from. And over time, I learned that, really not all uncommon data types are inputs exactly. Some are internal system values generated by the PLC itself, and others are outputs the PLC sends to external devices. If it's input data, it can include ASCII strings from barcode scanners, numeric fault words from drives, or status codes like pound 16 or 16 pound 0000 underscore 8000. Coming from an Ethernet IP device, for example. Internal data includes like some system information to the PLC on its own, like in GSV values or module health, scan time, or controller status. Output data, it might be commands or responses to the PLC that the PLC sends back. ASCII messages to a printer or encoded words to a driver telling it to start or stop. It took me a while, it really did. I discovered that, kind of what makes these data types uncommon isn't really their direction, but how they're structured and how I have to interpret them. Once I understood that, I stopped seeing data as confusing and started seeing it as exactly what it's supposed to be. It's communication. Let me share an experience I had a few years ago. Once I was part of a project at Winnebago Industries. The division was working with was earning about $85 million a year, but they had a goal to grow to about $245 million. And they knew they needed automation to do it, so we put up $200,000 square foot facilities. We added advanced automation, at least advanced for the travel trailer industry at the time. We introduced CNC systems, automated climate control, automated conveyor systems, a secondary machinery into and basically an industry known for its traditional hands-on craftsmanship. At first the transition felt awkward for the production team. They seemed to resent me bringing in all this new technology, especially those who'd been building by hand their whole career. It was like trying to teach a master woodworker to trust a servo. Many resisted. They were used to the rhythm of people, not machines. But as the project took shape, something clicked. We weren't really replacing craftsmanship. We were scaling it. Automation didn't erase the soul of the process. It translated it into a new form. When I look back, I realized that manufacturing was doing exactly kind of what a PLC does when it converts incoming ASCII into usable integers, for example. We brought in raw materials, each in its own packaging, size, and form, and converted them into something useful for the end user. That's what automation really is. We take in these various data types, we convert it, use it, and then we send it out. And there was a connection made for me, and it's every automation engineer. They eventually learn that the data it can enter, move through, and leave a PLC like in many forms. And my job as an engineer is to adapt it, to translate it into logic that produces a usable output. That's what growth looked like in business too. Winnebago didn't lose its craftsmanship when it automated. It learned how to convert a larger volume of raw materials into the business and then convert them into a finished product that carries the same quality, just at a larger scale. In programming, as in life, the challenge is the same. I have to make sense of the input, convert it if necessary, and produce something meaningful on the output side. So nowadays, when I see something like a pound 99999 or ASCII text streaming across my program, I know it's a sign that something's being converted. Some of that data is coming in, some is internal, and some is going out. My job isn't to change it directly, right? My job is to interpret it, to convert it into something my system and my operators can use. That little insight helps shape how I think about my programming, and honestly, how I think about growth. Whether it's data and machines or people, everything comes in its own form. The real work is learning how to interpret it and convert it into something useful on the outside. So I hope that this is helpful. It was helpful to me when I made this revelation. It made this uncommon data type. It made sense to me, and that leads me to the PowerFlex 525. We have a great troubleshooting course for the PowerFlex 525. A great little tool. It's an interactive simulation. I think you're going to find some real value in it. Again, it's looking at a tool, and I'm trying to understand how to use that tool so in a way that produces an outcome. All right, this is Paul with Inside Logix, and if you want more useful insights like this, stay in touch, all right? Cheers.